Okay, let's talk about Coulomb's law in a vector form. Okay, till now we didn't write this Coulomb's law in a vector form. Okay, and I will tell you why it looks complicated in a vector form. Okay, so let's look at this. Suppose we have Q1 and Q2, and let's say the distance between these two charges is, let's say, R. Okay, the distance between two charges is R. Now Q2 will repel this Q1 charge in this direction, and Q1 will repel this Q2 charge in this direction, right? Now the force on Q1 due to Q2 is written as, F12 bar. That will be in this direction, right? Left direction. And the force on second charge due to the first one is F21 bar, right? Okay. Now how will I write this F12 bar? Okay, in a vector form. So F12 bar will be K Q1 Q2, till now everything is scalar, divided by R square, right? Now what is the direction of F12? Okay, see, if I take this as my origin, this as my origin, that is, this is my reference frame. I'm sitting on the charge Q1 and observing it. Okay, I'm sitting on the charge Q1 and I'm observing that charge Q1, or I can observe that charge Q2. Let's look at Q2 first. Okay, I'm observing this charge Q2 while sitting at origin. Now this vector from O to this particular thing, this particular charge is written as R bar, right? It will be written as R bar. So now to write this F21 bar, the force is in the right direction. It will be K Q1 Q2, of course, divided by R square, and the direction is which? Along the line joining these two charges. The electrostatic forces is a central force. That means it acts along the line joining the two charges. So this one is R cap. Okay, this is R cap. This is a direction of this force, right? The force on the second charge due to the first charge is in the right direction, and that direction is same as the direction of R bar, right? So this is the magnitude, and the direction is given by R cap, right? You know the unit vector times the magnitude is that vector. Similarly, this vector, if I look here, see, this is R cap direction. Now this will be what direction? Minus R cap direction. So I will write here as minus R cap, correct? Now you can see from here F12 bar is minus of F21 bar. So these two forces are equal and opposite direction. F12 is in this direction, F21 is in this direction. Equal and opposite forces, right? Newton's third law, right? Okay, so now the question is, what if I do not take this as my origin? You see, I can take this also as my origin. The things are very simple, right? If I take this as origin, things are very simple. But now if I am observing from another point, right? My origin is somewhere here. Then the difficulty arises. I cannot write it in simple form like that. I have to introduce another vectors. So this is the reason. When you change your reference frame, you have to write the Coulomb's law in little complicated form. Okay, so let's look. Let's say I have a reference frame. This is x-axis, this is y-axis, this is z-axis, right? Z-axis is coming out of the plane like this. It's not going in this direction, it is coming out of this. This is x, this is y, right? And this is origin where my observer is sitting. And I am observing two charges. Let's say here there is a charge Q1 and here there is a charge Q2, right? I am observing the two charges. Now the vector that gives the position of the Q1 charge is your R1 bar vector. This is going to be R1 bar vector, and the position of the another charge Q2 charge is given by R2 bar vector, right? Okay, now see, let's say this is the distance between these two, Q1 and Q2 is the distance between, see this line, if I draw this like here, this is the distance between Q1 and Q2, right? Now I want to write the force between Q1 and Q2 in terms of R1 bar and R2 bar, right? Okay, so now what is this vector? Can you see? See, if I write this R2 bar plus some vector, R2 bar plus some vector x bar, let's say this vector is x bar. So R2 bar plus X bar is going to be R1 bar, right? R2 bar plus X bar is going to R1 bar. So X bar is equal to R1 bar minus R2 bar. So this vector is R1 bar minus R2 bar. This is the vector, right? And this is the magnitude of the magnitude of this vector is this length, right? Okay, now obviously you know the Coulomb force will be written as K Q1 Q2 by the distance between them, magnitude R1 bar minus R2 bar square. This is simply the force between the two charges Q1 and Q2. But now I have to write the magnitude along with the magnitude direction as well I have to write. Okay, now to write the direction we use one notation, right? So we write R1 bar minus R2 bar as R12 bar. Okay, R1 bar minus R2 bar as R12 bar. So here I will replace this R1 bar minus R2 bar as R12 bar. This is the direction of the vector, right? Now the force, if both of them are positive, let's say this is positive, then the force due to Q2 charge on the first charge will be in this direction, right? That is what the force on the first charge due to the second charge, right? F12 bar. Now similar way you can write the force on the second one due to the first one as F21 bar. Okay, now F12 bar is nothing but, okay, I will write it here, let's not write F12 bar. It is obviously this same magnitude K Q1 Q2 upon R1 bar minus R2 bar can be written as R12 bar. This is a notation, okay, there is no new physics in that. This is notation. So this is R12 bar magnitude square. Now what is the direction of that? See, the direction of F12 bar is in this direction, which is the same direction as R12 bar. As I said earlier, the forces between Q1 and Q2, the electrostatic forces, are along the line joining the center of the charges. So R12 bar's direction is the same direction as F12 bar. So I can write it as R12 cap. R12 cap, right? Okay. Now the force on Q2, is F21 bar, right? Correct? The force on Q2 is F21 bar. Now the force is in the opposite direction. The force is in opposite direction. So if I write it K Q1 Q2 divided by, how will I write this now? The force is on the 2 due to 1. See, the distance is same, right? This is R12 bar magnitude square into R12 is like this. F21 bar is in opposite direction of R12 bar. So it should be R12 bar minus, okay? So this is minus R12 cap, right? What is minus R12 cap? See, for R1 bar minus R2 bar is R12 bar. Similarly, you can write R2 bar minus R1 bar as R21 bar, right? This is what vector? The vector like this, okay? I will redraw it here so that you can understand. Otherwise, you will get confused. So this is R1 bar and this is R2 bar. If you want to find out this vector, let's call this vector as some alpha bar, right? So R1 bar plus alpha bar is equal to R2 bar. So alpha bar is equal to R2 bar minus R1 bar, which is R21 bar, right? So this alpha bar is R21 bar, correct? So alpha bar is R21 bar, which is opposite direction of that of R12 bar, right? R12 bar is like this, R21 bar is like this. So I can safely say R12 bar, R12 cap with a minus sign is nothing but R21 cap. See, R21 is like this, R12 is like this. So if I multiply with the minus sign, then this will become R21 cap like this. Simple logic, right? So this is going to be K Q1 Q2 upon, now R bar 1 2 magnitude is same as R bar 2 1 magnitude. Magnitude of R1 bar minus R2 bar is same as R2 bar minus R1 bar, right? So you take the direction like this or this, but the magnitude is going to be the same, right? So I can write this as R21 bar square into minus R12 cap is R21 cap. So this is your force on the second due to 1. So this is how they write the forces. Okay, so this is how you write the vector form, the Coulomb's law in a vector form. Now if you do not want the unit vector over here, simply take a normal vector, but now this should be made cube, right? So this will be, right? Okay, that is this visible? Okay, let me try to squeeze it here. Okay, R12 bar, R12 cap, sorry, is nothing but R12 bar divided by the magnitude of R12 bar, right? Correct. If I substitute this value here, so it will be F12 bar is equal to K Q1 Q2 upon R12 bar magnitude square into R12 bar and divided by R12 bar magnitude again. So this will become cube. Similar logic you can apply for F21 bar and you will get K Q1 Q2 upon R21 bar magnitude cube into R21 bar, right? So you can write in this way as well. So this denominator will become magnitude cube. Okay, all these things is looking complicated, but don't worry, you will not use that much. Okay, you will not use these things that much. All these things became complicated because of our decision to change the origin from this charge to this charge. And of course, we should not keep the origin on one of the charges, right? Because if many charge system is there, then it will be little difficult. It is better rather to have a origin somewhere else rather than on the charges itself. Okay, so anyways, so this is the way you write the Coulomb's law in a vector form, right? In the next session, we will see the superposition principle and we will see some problems based on Coulomb's law in a vector form. Okay, thank you.